Hi everyone. Today we want to move on and talk a little bit about this book. And remember, I talked to you about this book at the day one of this class, and I say, well, this is not a book for the beginners who started coding Python. Well, this is Effective Python: 59 specific ways to write better Python. So this book is definitely for experienced programmers. And I know, well, for you guys, well, you have at least programmed Python for one semester. So, well, you kind of know this programming language well enough. So I can start part of the topic from this book. Okay, well, the first thing I want to say is, well, Python is kind of a unique language, or I should say, for each different programming language, they are unique in a certain way. Okay, well, let's use my experience as example. I started coding when I was in college. My first language was C, and then C++. And then when I started doing my master degree, I used Java a lot. And then when I was doing PhD, I started to do Ruby. And then, well, when I started teaching, and then I used Python more. So C, C++, Java, and then Ruby, and then Python. Well, and all those languages are a little bit different. Well, and sometimes when you are maintaining a project written in one language, for example, Ruby, and then you see someone else contributed some code. But when you review that code, even though the syntax is 100% correct, the syntax is really in Ruby. That is exactly the language this system is developed. But, well, the code doesn't really look like Ruby. It looks like another language, for example, like Java or C++. So why? Even though the syntax is 100% correct, but there are some conventions that the developer of a certain language had this convention that we should do that in one way, not the other way. Well, and for example, the most obvious thing is, well, the naming of the variables. If you are a Java programmer, and then you tend to use more of the camel cases, and in Ruby and also Python, we tend to use the snake cases, right? Okay, so let's see what we have in this lecture. Well, the number one thing, you want to know what version of the Python you are using. Well, if you're using the command line, well, given you have already got a Python installed, and then you can do Python hyphen version, and then you may have a Python 2, or you may have a Python 3. Well, and if you are in Python 3, it doesn't matter too much if you are in Python 2, 3.4 or 3.6 or 3.8. Well, it doesn't matter too much, but if you're in Python 2, well, probably the first thing is you want to upgrade your Python. Well, because in a lot of cases, you may have a Python 2 pre-installed into your system, and you don't really know about that. And then, well, if you don't do the proper configuration, and by default, your system will run Python 2 for you. Okay, and then in Jupyter Notebook, and this is our trick, and then we can get the version of the Python. So if you have a new Jupyter Notebook setup, and then this is the easiest way for you to check the Python used for the Jupyter Notebook. Okay, well, and talking about the convention of the Python coding, and there are multiple conventions online, and probably the most popular one is the PEP8. Well, this is there could be something else if you are working for a specific project in a specific company, but in the industry, and PEP8 is one of the most commonly used one. Well, let's see some of the most obvious and the easiest ones. And for example, use spaces instead of the tab for indentation. Well, for the indentation, and for example like this one, well, we usually will do spaces, well, in Python. But if you go to the older programming languages, and some of them are using the horizontal tab. Well, the width of a horizontal tab is exactly the width of 4 spaces. So probably you can't even see the difference. But in Python, it's our convention that we are using spaces instead of a horizontal tabs. Well, and also, well, you may find this is weird. Well, a line should be 49 characters or less. Okay, so if you're writing a super long line of the code and then according to the PP8 and you are wrong, well, this wrong is not on the syntax, but it doesn't look that your code doesn't look that Pythonic. Okay, you're coding the right syntax, but the code doesn't look quite correct. Well, and if you are trying to continue your line in the next line, and then what you are going to do is you have to do a further indentation. So what do I mean this? Say you have the I equals 1 plus 10 plus 100 and then plus 1000. Okay, and then, well, I say, okay, this line is already long enough. And then can I do this? Well, the answer is no, because this will be considered as one line and then this will be another line. So you have to add a backslash. Well, even after you add the backslash, the indentation should be like this. So you have to indent the second line even further. Okay, and in a file, and if a function and the classes should be separated with 2 blank lines. Say, for example, I have the first function definition, my fancy func, and then colon. And then after, I think I want to do something very quick. And after that, if you want to define a second function, and then there should be 2 empty lines between. So then I can do a define another func parentheses like this. So the point is there should be 2 lines between the definitions. Okay, well, and put one and only one space before and after the variable assignment. So that should be like this one. So for this one, well, when you are doing the myString equals hello from a function, well, there should be a space before and a space after. So for this part, the problem for this line is we want to use 4 white spaces. If you are using 2 white spaces, well, is this code correct? Well, I have already run this code, so you can tell it is correct. However, the problem is, again, the code is not Pythonic. We want to use 4 spaces, and then 4 spaces, and 4 spaces. Okay, well, another thing is, well, in Python, when you are doing the print, well, this print will be a function cal, right? When you are doing the function cal, and then you don't have to use a space between the function name and the parentheses. Well, even though for this way there's nothing wrong, but this space is not necessary. Well, this space makes your code less Pythonic, so you want to take this out. And another thing is, how about this one? Well, this is the square bracket, and again the problem is you don't have to use the space here, even though it doesn't break your Python interpreter, but this makes your code looks weird. Okay, so you want to fix like this. Okay, so let me revert everything back and let me take this out. Okay, and let's move on and talk about naming convention. So for the naming convention, when you are naming variables or attributes, you are going to use the snake case. So that is one word, all lower cases, underscore, another word, all lower cases. Okay, and then, well, when do we use the camel case? Well, we use the camel case when we have the class name or exceptions. Okay, those are 2 cases in Python that by convention we do use the camel cases. And if you see someone else writing the program using the camel cases for the function name or using the camel cases for the variable name, and that's not correct. Okay, well, and for example, if you see a variable name like this, well, this is definitely in Java style. Probably this person did Java a lot, and then this person just started coding Python. So a lot of the habits are still brought from Java. So even though this does not break the Python interpreter, so when you run this, it runs, but this code just look a little bit weird. And then this one will be a correct version. Okay? And for this thing, well, my function, well, this is also wrong because you want to use the underscore my underscore function instead of my function with the F capitalized. Okay? And after that, here, this is also wrong. You have to use 4 spaces instead of 2. Okay, and then we can do even more about the expressions and statements. Well, here is one important argument. Well, even though Python gives us a lot of the flexibility and we can do things in different way, but inside a community, people want to agree that we want to do things in one way, and that's the only one way acceptable. So in other words, Python gives us too much flexibility. And now, using a coding convention, we want to put some constraint so people are using the same way to do the same thing. Okay, and well, for example, let's see this one. Well, don't check the empty values. Well, and for example, if you have a empty list or a empty string, well, and usually if you want to check whether it is empty, you want to do something like this. So if the length of the list equals 0, right? Well, this syntax is definitely correct because we are using the len function to grab the length, and then we are checking whether the length is 0 or not. So from the syntax, nothing is wrong, but there are better ways to do so. And how do we do that? Well, say I want to do a sum list equals a empty list, and then I say if the len of sum list equals 0, and then print empty. Okay, so if I run this, it doesn't run. What's going on? Oh, my syntax is wrong. Okay, it should be like this. Okay, run. Okay, it runs, and then it gives you it is empty. So indeed it is empty, and then this program from syntax, that's correct. But well, you should know this. Well, in Python, if we just do this version. So if sum list, and then well, if sum list means well, the sum list, even though it is a list, it will be evaluated as a boolean. So if the rule is if it is empty, it will be evaluated as false. Otherwise, as long as there is any item inside the list, it will be evaluated as true. So if this one has any value, and then I will print there is at least one value, and otherwise I'm gonna print empty. Okay, so if it is empty list, and then it will be evaluated as a false, so I will go to the else branch, and then I'm gonna do empty. So if you run this version, and again we got empty. So you don't have to grab the length and then check if it is a 0 or not. Okay, well, and there are some other obvious things. And for example, you want to avoid one single line if statement. Well, that means something like this. So if Apple, if is Apple equals, well, and then we have a one-line expression. This one-line expression is, it is true if the apple is indeed, the fruit is indeed a string of apple, otherwise a false. Well, it's in one line, we are doing a comparison and then returning a true or false accordingly. Well, and we can compress if if branch, else branch, a total of 4 lines of code into 1 line of code. And in the Python convention, well, this is not recommended in the PEP8. Well, we would rather spread that over over multiple lines just to make the code a little bit more readable. Okay? Well, and there are also something about the import. So we want to do when we want to import something, and you want to do import from a package, import a module name. So you want to do from, and then you want to do from bar import foo instead of just doing a import foo, just to be clear. So there are really a lot of things, and you feel free to read the full list, or if you want to borrow this book, I believe there is a book in the student lounge in the Friday Annex as well. Okay, so let's see this one. Well, if the length of the sum string is equals to 0, and then I'm going to print this is empty. Well, and then we want to do this one. If this is an empty string, and then I'm going to do an empty string, and otherwise if not empty string, if not empty list, and then I'm going to do list empty. So again, for this part, and remember, if we have an empty object, it doesn't matter if it is a string or if it is a list, if we are putting that right after the if branch. So if, and then a sequence, and then Python will evaluate whether this sequence is empty or not. If this is empty, that will evaluate it as false. If there is at least one value inside, and then it will evaluate it as a true. Okay, and here is another thing we want to talk about. That is how we want to handle the arrows. Well, in Python, Python is really a flexible language. And for example, when we are sending a argument into a function, well, we don't have to say, well, this number has to be an integer, or this number has to be a float number. In Python, we don't really do that. Well, this is flexible, but this also causes a lot of problem, because say this function will later be used by another part of the program, not written by me, but written by another person. And then, well, what if this person is careless? What if this person is sending a theory in pandas instead of a number? So in this case, I really want to make sure to guarantee that I'm receiving the data type I'm expecting before I move on and do more of the work. So here is how we can do that. So if the number is not an instance of an integer, so this means this is not the data type I'm looking for. So I'm gonna say I'm gonna raise an type arrow. Well, and remember, for the type arrow, this is type of an exception. So we are sending an exception to our user saying there is something wrong. And then, well, even though the program doesn't work, at least we are tailoring the arrow message. Say if later, after I finish this function, I know someone else is using this function, it's better that I'm putting some constraint before the real body of this function. So the other person, even he tries, he might be careless, and then he didn't send me the right parameter, and still I can give some meaningful output. Say, for example, I want to do a factorial, say a string hello. Okay, and then if I run this, and I will receive a type arrow, and then the sorry, and then the type arrow is sorry, number must be an integer. Okay, so how I tailor that, it is exactly here. So when I see the number is not an instance of an integer, and then I'm going to raise a type arrow, and then I can also tailor this arrow message. Or I can say, well, if you have question, talk to Yang. for example. Okay, and then if I run this again, and well, you will see this error message will be like this, especially when you are doing the collaborations with other people and using this kind of the safe net for some of your functions might be really necessary. Okay, so let me revert back. And here is another thing. If the number is not greater than 0, and then we can say, okay, there it is also wrong. And in this case, I want to raise a value arrow. And the value arrow is this number must be 0 or positive. Okay, so well, and then we have this part. So this is again a function inside another function, and we have seen this before, right? Okay, so well, now let's see an exercise. Well, we want to do this. How do you check if a data frame is empty or not? Well, and remember, well, if we are doing, if a data frame works in the same way as a string or as a list, and then we can do if data frame, and then by doing the if data frame, it will check whether the data frame is indeed empty or not. So I know it works for lists, it works for strings. So does that also works for data frames? Okay, so go to this box and play with this code a little bit and try to figure out how do we check whether a data frame is empty or not. And I will show you my answers in the next video. Okay?